There is a handout that will be on the Canvas course, or it will also be given to you in class. Let's look at isomers. So in organic chemistry, so this is carbon chemistry, there are many different combinations that you can do with a carbon. When you bond with a carbon, there's always 4 bonds. And because there's 4 bonds, there's lots of things that you can attach. Let's look at something called an isomer. So that means that you have the same formula, but it is a different molecule, and that's because it's bonded together differently. Let's look at this first one. This is called a chain isomer or a skeletal isomer or a structural isomer. What it means is that the carbons are bonded in a different way. Here, they're bonded in a row, and here you can see I have a chain of 3, and then the 4th one is on the middle carbon. So whenever you have a single bond, those bonds can twist. There's no way that you can take this little T-shape molecule and twist it into being straight. So these are different molecules that have different names. This is a butane, this is a propane. You're not expected to know naming of these organic hydrocarbons, but you should know how to draw a structural isomer because I have seen that on the AP test before. All you do to go from this one to the second one is you take off one of the carbons and you put it on a middle carbon. So you actually switch the hydrogen with that carbon and 3 hydrogen group. So again, you put it on the middle, not on the side. If you were to take off the carbon and put it on the end, well, that's still straight, even though it's kind of bent up like that. It's still straight, 1, 2, 3, 4. So again, you take off the carbon and you put it in on a middle carbon. And then make sure they all have 4 bonds, so you'll surround it with the hydrogens. A positional isomer, this means that you have something that's in a different position. So on the first one, we have a chlorine that's on the end, and now the chlorine's on a middle carbon. And there's no way you can twist that around to make one become the other. So they actually have 2 different names. And on this one, you have a double bond. So this double bond is between the first and second carbon. And this double bond is between the second and third carbon. And again, no matter of twisting can make one turn into the other. A functional isomer, that means that you have a functional group. So something other than carbon is bonded in a different way. So on this first one, you can see that you have your carbons right next to each other. And then on the second one, you have the carbons that are separated by an oxygen. And they make what is called a functional group. So this little OH group, this is an alcohol. And when you have this little O in the middle of a carbon, then it's called an ether. So the alcohol will smell like alcohol, and the ether, it smells sweet. Here are the functional groups, so you should be familiar with these. So an alkane just means you only have single bonds. An alkene, there's a double bond, and an alkyne with a Y has a triple bond. You can have a phenyl group or it's basically a benzene ring. And then here we have a halide, so that would be a halogen that is on a carbon. There's an amine. Here's that alcohol group I was talking about. There's the ether one we were talking about. If you have a double bond O and then an H, that's called an aldehyde. A ketone is a carbon chain, and a center carbon will have a double bonded oxygen. Carboxylic acid, these are organic acids. In our acid-base unit, we'll be talking about those a lot. An ester looks like that. And then we have an amide, which is this NH2 group that's on the end within double bonded O. So a lot of this is done in biochemistry or organic chemistry, but I would expect that you could draw an isomer, which is carbon and hydrogen, and I would expect you to recognize these functional groups. Not draw them, but just recognize by saying that's an alcohol or that's an amine. A stereoisomer, so this means that you have the same connection order, but because there's a double bond or another circumstance, it is something different. So this first one, there's a double bond carbon. We have this carbon group that is close to each other, and this carbon group that is far away from each other around the double bond. And so this is an isomer. So this is a cis isomer. I always remember this like sisters or close. And then this is a trans isomer, like a transcontinental railroad travels far, so the functional groups are far away. But again, they're both isomers because they have the same number of atoms. And in this case, they're bonded the same order, but this double bond locks it into place so it can't twist. And so you get the groups that are close and the groups that are far away. Optical isomers are really interesting. These are evolved a lot in our bodies with like enzymes and medicines, and they are mirror images of each other. So you might say, oh, they look the same, but just like your hands, you can't put your hands on top of each other. You're going to see that they are different. They're going to be mirror images of each other. Your hands are mirror images, and these molecules are mirror images also. And how you get these is you have a carbon that has 4 different groups attached, and there's different ways that they can attach, and you can get that mirror image. The AP board likes to use organic molecules for some of your test questions, so I just want you to be a little bit familiar with at least carbon molecules so that if you see something on the AP test, it's not a shock. You will not be asked to name ever. I will not ask you a test question on how to name something, but it is interesting how you name these carbon molecules. So carbon always has 4 bonds, and then you count how many carbons you have, and also you look and see if there's any double bonds in the molecule, and then that's how you name it. So this only has single bonds, and so this one would be methane. So that ANE group says it only has single bonds, and the meth means I have 1. If I were to take off a carbon and add another carbon group, then that would be ethane, and etc. So I could just keep adding carbons, and if they're all in a chain, then I could name them. If I were to put a double bond in here like that, well, then I wouldn't have ethane, I would have ethene. So that would tell me that I have a double bond in there. So an example quiz question that you might see for me or the AP board is just asking about the functional groups. So this first one, I can say I have a carbon chain, but then I also have this OH group. So you should know that this is an alcohol. And then the second one, I see I just have this double bond O on the end. So this is an aldehyde. And on this one, I have a double bond oxygen on a middle carbon. So this is a ketone. And on this one, I have a double bond O and then an OH group. And it's not an alcohol. This is a carboxylic acid. And last but not least, I have this NH2 group. So this is an amine. So we've already gone over this. Single bonds end in A and E, at least 1 double bond in E, and then 1 triple bond, an ine. This just goes through and shows some of the characteristics. So ethane have kind of a gasoline odor. Alkenes, they have a sweet odor. So do alkynes. And these benzene rings, they also smell sweet. When you're drawing hydrocarbon chains, it can become quite tedious to draw the 4 bonds around all the carbons and then make sure that something is connected to those carbons, at least hydrogen. And so we use some sticks and elbows to do this. So every time you see an end, there's a carbon there, and every time you see an elbow, there's a carbon there. So we can see that this is a 6-carbon chain. So this is hexane. They're all single bonded. And we just don't draw all the hydrogens, but it's assumed that they are. Let's look at this next one. So the next one I could draw like this. And then the bromine, I would just stick on there, or it would be the same thing. It would be right here. So that would be a, what is that? 2-bromo-propane. And on this next one, if there's a double bond, you can just draw it. So the next one, I would have a pentene. It would be like this, and it's between the first and the second carbon. And then the other one is between the second and the third carbon. So you just represent it like this, and it's just a quick and easy way to draw your hydrocarbons. And remember, a hydrocarbon is like a carbon chain, so carbon with hydrogen surrounding it. Stop the tape and see if you can find the functional groups and name them. Okay, we're back. The first one is an alcohol because of that OH group. The second one is our carboxylic acid. The C, the third one, is interesting. I have an amine on one side and a carboxylic acid on the other side. So this is what's called an amino acid. So the building block of protein. D is an aldehyde because I have that double bond O at the end. We have E, there's a double bond O, but it's in the middle, so that would be a ketone. And last but not least, we have an amine with that N double H group.